All right, let's get started with part 1 of Module 7. In this part, we are focusing on rational number core concepts that we should emphasize within intensive intervention. So in this part, we are going to learn the core concepts about fractions and the core concepts about decimals. Let's go ahead and get started. So when we're thinking about rational numbers focus on understanding fractions, decimals, and percentages. And rational numbers are absolutely essential for everything the students are going to learn after this, especially algebra. There are several really good research studies that show when students have a strong understanding of fractions, those students do better when they're thinking about algebra in 8th grade or algebra in high school. So let's focus on fractions today, decimals, and percentages. But we're going to spend most of our time right here on fractions. So when we're thinking about fractions, we have to introduce vocabulary about fractions to students. So some of the vocabulary that are really important for students to understand revolve around understanding we've got a whole. That's not a hole that we dig in the ground, but that's a whole that represents a fraction. And that whole is broken into equal parts, and each one of those equal parts represents a unit. So when we have a unit fraction, that is a fraction with a numerator of 1, like 1/4 or 1/3. Each of those represents one of the equal parts of the whole. We also have different ways to explain fractions. So we have proper fractions. Those are fractions that are less than 1. We have improper fractions. Those are fractions that are equal to or greater than 1 and represented without a whole number. And we have mixed numbers, which is a mix of, and if I scoot to here to the side, you can see it, a mix of a whole number and a proper fraction, but this is a mixed number, and it also is represented, can be an improper fraction. And as we look at all of these fractions, we focus on the different parts of these fractions. So we have the numerator that represents the parts of the fraction that we're showing, and we have the denominator that tells us how many equal parts that whole is broken into. Now, one thing that's really important when we talk about fractions is each of these fractions is a separate number. So 2/3 is one number. It is the number 2/3. It is not made up of separate numbers. So there's not a top number and a bottom number. There's a numerator and denominator, and together those work to make one number, and that number is 2/3 or 9/5 or 2 1/4. So let's focus on the different models of fractions. Students need to see and experience fractions in different ways. And so they should have familiarity with all three of these models. I'm going to introduce them pretty quickly, but knowing within intensive intervention, you'll probably introduce one model, practice that for several days or even several weeks. Then you might introduce another model and then practice that model. So while we're going to go quickly so that you gain all of this information, just remember that you would introduce this information a little bit more slowly to students. So the first model that we're going to focus on today is the length model of fractions. And how I'm going to do this is I'm going to show the representation of these fractions, and then I'm going to go over to my table and I'm going to show the concrete representation of these fractions. So how you can show these different representations using the concrete and the representational. And I also have the abstract right here. Remember, we always want to be showing the abstract form of our number so that students understand how all of this works together. So let's focus first on the fraction 2/3. I'm going to show this with fraction bars or tiles. That's a pretty common representation to use with the length model of fractions. So the first thing when I'm thinking about my fraction, I have my fraction 2/3. And when I'm going to represent fractions, either pictorially or representationally, or with the manipulatives, which I'll do in just a minute, I always want to focus on the denominator first. So here my denominator is 3. That tells me that I have a whole, and that whole is broken into 3 equal parts. I have those equal parts here, 1, 2, and 3. Now I focus on my numerator. My numerator is 2. So that means I'm going to show 2 of those 3 equal parts. So I'm going to take that one away to show the fraction 2/3. Now you might be asking yourself, why is this the length model of fractions? Well, this is the length model of fractions because I can envision this representation as falling on a number line where here is 0 and over here would be 1 right there. And so then I can see that the value of 2/3 falls somewhere between 0 and 1. I can see that the 2/3 is not greater than 1. I see that it's less than 1. And if I have an understanding of where 1/2 is, which would be right about there, I can also see that 2/3 is greater than 1/2. So this length model of fractions allows me to understand the magnitude of the fraction, or the fraction's value. So this is what it would look like with the representational. I'm now going to move over here and show you what it's going to look like with the concrete. So here I have my whole. I'm going to do the same fraction, 2/3. I'm going to show my whole right there. And I understand that that whole has a denominator and it's broken into 3 equal parts. So I'm going to show those 3 parts. Now I can do this 2 ways. I can show my parts right here, like basically on top of the whole. I could also put the parts literally on top of the whole to show that that whole can be broken into 1, 2, 3 equal parts. Now I'm not done here because I want to show the fraction 2/3, which means I need to show 2 of those 3 parts. So here is the fraction 2/3. I'm showing 2 of the 3 parts. I could also show it like this. Here are 2 of the 3 parts. Remember, this shows the length model of fractions because we have 0 over here and 1 here. And I could think about this as just a continuous number line where I could actually show fractions greater than 1 in this space over here. Now I do want to show one thing that I have seen some teachers do that is really a no-no. And that is to show the fraction 2/3 in this way, all right? If I show 2/3 in this way, it does not match the abstract form of the number. And in fact, to me, this looks maybe like 3/2, maybe like some other fraction. When I show 2/3 this way, I see the numerator on top and the denominator on bottom. Or if I show 2/3 this way, the numerator is on top and the denominator is on bottom. If I do it this way, it's not following that convention. So this is a non-example. We would want to do something like this or like this for the fraction 2/3. Now these are fraction tiles or fraction bars. Lots of schools have these, lots of classrooms have these, so you might have access to these. And they're a really good manipulative to use to help students understand the length model of fractions. But we have some other options as well. So I want to look at another manipulative. These are called Cuisenaire rods. Your school might have these. Often they're used in the younger grades for counting. That's mostly where we will see them. You might use them for addition and subtraction, but we can also use them for fractions. And these Cuisenaire rods have a little bit of an advantage excuse me, over the fraction bars or fraction tiles, and I'm going to talk about that in a minute. So I'm going to go back to my fraction 2/3. So remember, when I'm talking to students about showing a fraction, I'm not going to focus on the numerator first. I'm going to focus on the denominator first. So here I have a whole, and that whole is broken into 3 parts. So I'm going to find a whole, all right, and I've still got my length model. Here I've got my 0, and over here this represents 1. And then I'm going to break that whole into 3 equal parts and show 2 of those parts. So here is the fraction 2/3. Now with the Cuisenaire rods, the nice thing about them is there's not just one way to show a fraction, but there are actually several different ways. So here is a whole. There's my 0 and 1, just to help you remember that. Here is a whole, and then I can show 2/3 of that whole. Here's 0, and here's 1, and this also represents the length model of fractions. Now the nice thing with the Cuisenaire rods is that students really have to figure out how to take this whole and break it into those equal parts. And not all wholes can be broken into the same number of equal parts. So for example, this blue rod, it would be very hard to break this into 4 equal parts, but it works very well breaking it into 3 equal parts. But here are 2 representations, and now I'll show us what it'll look like with our Cuisenaire rods. So take my fraction tiles away. And now I'm going to get out my Cuisenaire rods. So here is a whole, and I could do the whole thing where I have to experiment. I can take that whole and break it into 3 equal parts, and I'm going to show 2 of those 3 parts. But I could also take this whole and break it into 3 equal parts and show 2 of those parts. And I can get crazy today. I can show this whole and break it into 3 equal parts and show 2 of those parts. So what we've done here is we've made multiple representations of the same fraction. Now when we have the fraction bar, I'll put it up here to help us remember the fraction bar, and then I'll slide it down so we can all see it there. When I have the fraction bar, I only have one option. I have my whole, it is always this long, and when I'm thinking about thirds, they are always these pieces, they're always orange, and most likely they are also labeled with 1/3. So that's helpful for understanding fractions, but it's not really challenging students in terms of good fraction understanding. But let's look at the Cuisenaire rods. I can take this blue whole and break it into 3 equal parts. I can take this lime green whole and break it into 3 equal parts. And I can take this dark green whole and break it into 3 equal parts to show 2/3. So with the Cuisenaire rods, you often have many different ways to show the same fraction. And students really have to think about that denominator and think about the equal parts of the denominator in order to be able to show the fraction. So the Cuisenaire rods give you a much more flexible model for showing fractions. They are still the length model because I consider the left side of my whole 0 and the right side of my whole 1. So 0, 1, 0, 1. But my whole isn't always this long, and it's not always red. I'm really having to think about what the fraction is and how to represent that fraction. So now we're going to look at the next model of fractions. So we're going to think, there's our length model of fractions. Oh, we're not going to look at the next model of fractions. I have another representation to show you. I've got the number line. So it's talking about the fraction tiles and talking about the Cuisenaire rods and how those represent basically a number line that we can place the fraction on. And we should also use number lines. When students can place fractions on number lines, it shows a very expert understanding of the fraction. So here's my number line. On this number line, this represents 0, and here I've got 1. I can break this number line into equal parts. So I have 1, 2, 3 equal parts, and to show 2/3, it would fall here on the number line. So again, I can see that 2/3 is less than 1, 2/3 is greater than 0, and if I understand the benchmark fraction of 1/2, I can see that 2/3 is greater than 1/2. So with this length model of fractions, we're always helping students really understand the magnitude of the fractions. So I showed fraction tiles, or you might call them fraction bars. We also looked at Cuisenaire rods, and we also talked about the importance of number lines. So when you're introducing fractions to students or helping students practice fraction concepts, make sure that they understand fractions as appropriated by length. Hi, welcome to Workbook Activity number 1. In this activity, I want you to look at how the student represented 4/5. And then I want you to think about how you could use the length model to help this student understand that fraction. I'd like you to both draw and write your response. All right, now let's talk our second model of fractions, and we are going to focus on the area model of fractions. The area model of fractions is that we can take any area, break it into equal parts, and it can be used to show a fraction. So here we have our very classic area model of fractions, because so many people like to tell stories about pizzas and cookies and pies. You can do a little bit of that, but don't do that much, because it's a little bit of an overused model, and it actually is not that helpful for students to always think about fractions in a circle like this one. So I'm going to go back to my fraction 2/3. We're going to hang out with 2/3 all day today. It's my favorite fraction. And with 2/3, I've got my whole. So here is my area, or my whole, and that is broken into 1, 2, 3 equal parts. Then I look at my numerator, 2, and I need to show 2 of those parts. So I've shaded those in blue. So 2 of the 3 parts are blue, so I've showed the fraction 2/3. Now this is the representation. Now let's look at what it might look like in the concrete. So here I've got my fraction 2/3. Remember, I'm always going to show my whole first. So here is my whole. And I'm going to take that whole and break it into how many equal parts? 3. because our denominator shows that I'm breaking that whole into 3 equal parts. Now I look at the numerator, and I want to show 2 of those 3 parts. So here is an area, and I'm showing 2/3 of that area. Now I've got my fraction circles. Probably most of you have those in schools. You've probably got it to use in your classrooms, and they're okay to use. But in the same way that we're thinking about the fraction tiles and maybe how the Cuisenaire rods or number lines might be a little bit better to use for the length model of fractions, we have some other representations that might be better to use when we're thinking about the area model of fractions. So I'm going to show you a few of those now. So I could use a geoboard. Lots of schools have these, and many people think that they are a great geometry tool. They are a great geometry tool, but we can also use them for fractions. So here is my geoboard, and I'm going to show the fraction 2/3. So I'm first going to focus on the whole. So here I can take a rubber band. This is an orange rubber band, and I can break that rubber band into an area that has 1, 2, 3 equal parts. Then I take a different colored rubber band. I think I'm going to use a blue one here today. And then I can ring that around to show 2 of the 3 parts. So what fraction did I show? I showed the fraction 2/3. I can show it in many different ways on the geoboard. Here I have a whole broken into, and I can think about it as 1, 2, 3 equal parts, or 1, 2, 3 equal parts. Lots of ways to think about it. Get students to think about the fractions in a creative way. And I'm going to take my blue rubber band and ring around 2 of those 3 parts. And I can even do something a little bit crazy like this, all right? Here is an area, and I can think about that area as broken into 1, 2, 3 equal parts. And I can ring a rubber band to show 1, oops, did I make a mistake there? Oh, this is the one I was thinking about. So we can also use the rubber band to show the part of that is not the fraction. So here I used my blue rubber band to show 1/3, and so the orange rubber band shows 2/3 of the fraction. So we can do it in different ways, and that's what I was trying to show there. The other thing I'm trying to show here is that I also have an area that's not nice and regular. So I kind of got this like weird L or C or U if it's a sideways thing. There's lots of different ways I could describe this shape, but it is still an area. And if it's broken into equal parts, I can show 2/3 of the fraction, or in this way, I can also show 1/3 of the fraction. It can be any area. Doesn't have to be a nice clean circle or a nice clean rectangle. So now what I'm going to do is I'm going to show what this is going to look like over here if I was using the concrete model. So I'm going to move my fraction circles to the side. You bring those back a little bit later. Here is a pretty extensive geoboard. So this is not the typical orange one that a lot of people have. This one's actually a 10 by 10 geoboard, which is really nice when we think about coordinate grids. You can use it for that. But today I'm just going to do my fraction 2/3. So here I'm going to show an area, and I can break this into 1, 2, 3 equal parts. Then I'm going to take a white rubber band and ring around 2 of those 3 parts. I can do it on this side, which is broken into squares. I can also do it on this side, which is broken into different triangles. So here I could do an area that is broken into, let's see what kind of shape I want to make here. 1, 2, I'll kind of make an interesting shape to show how this works. 3 equal parts. And then I'm going to take one of my rubber bands and show 2 of those 3 parts. So my yellow represents the whole, and my green represents the fraction 2/3. Now there's other ways that I can use the area model, and I'm going to show those on my slides. So here is a pattern block. So probably a lot of you have these in your classrooms. Early grades teachers might have them for shape recognition. Later grades teachers might have these for use with geometry tessellations. But I can take this pattern block and I can break it into equal parts. And whoops, I'm going too fast there today. And then I can show 2 of those 3 parts. Now if I wanted to show that with manipulatives here, I've got my pattern block, and I'm going to break that into 1, 2, 3 equal parts. So this time my area is a hexagon, and I'm going to show 2 of those 3 parts. But the pattern blocks often allow us to do this in multiple ways. So here is a trapezoid broken into 1, 2, 3 equal parts, and I can show 2 of those 3 parts. I can also put pattern blocks together to show larger areas and break those into equal parts. And there's one other manipulative that I don't have on my slides because it was kind of hard for me to draw them, but I can use Legos. So here is an area, and it's broken into 1, 2, 3 equal parts. And my dark blue Lego represents 2 of those 3 parts. I could also have this stick that's broken into 1, 2, 3 equal parts. And I could put this turquoise piece on top. I'll kind of show it to the side like that to show the fraction 2/3. So it's an area that can be broken into equal parts. And that's what I can use to show the area model of fractions. So we've talked about we've got the pattern blocks, we just did the Legos. So we've talked about using the fraction circles. We also looked at using the geoboards. We looked at using the pattern blocks. You can also use the Legos. I didn't list them on here because it's probably against copyright rules, but I can say Legos out loud. But they're all areas where they're broken into equal parts, and I can show the parts of those fractions in that area. All right, so we just talked about fractions appropriated by area, and we looked at representations in concrete models with the fraction circles, the geoboards, the pattern blocks, and the Legos. Hi, now I want you to look at workbook activity number 2. Look at how the student represented 4/5. They tried to use the area model, but weren't too successful. So I want you to think, how could you use the area model to help the student understand the fraction 4/5? Go ahead and draw and write your response. Now let's talk about the final model of fractions, the set model of fractions. And the set model of fractions works with any 2 different types of manipulatives. And I'm going to go back to my very favorite fraction 2/3, and I'm going to show this fraction 2/3 with triangles and a square. So if I want to show this with triangles and a square, I could show 2 triangles and 1 square. So this represents the fraction 2/3 because 2/3 of this fraction are represented by the triangles. I can also show this with 2 color counters. Probably some of you may have these in your classrooms. You may have used them for counting or used them for things related to positive and negative integers, but we can also use them to show the fraction 2/3. So how I use those 2 color counters is we put out 3 counters because the 3 represents the denominator, or how many are in the set. And then I would flip over those counters, 1, 2, to show that 2/3 of this set are red. So I have shown the fraction 2/3. Now I have to think what this looks like with my manipulatives. So I'm going to go over here to my cool flip machine and click on DocCam. There we go. And now you can see both me and the DocCam. So I have these little frogs here. They are super cute, and they are going to help us show the fraction 2/3. So I have 2 orange frogs and 1 green frog. And so with this set of frogs, 2/3 of the set are orange. So I have shown the fraction 2/3. I also have my 2 color counters here. If you want to see this in real life to see exactly how this works, here I have my 3 counters. I like to put them in a set like that to show that they are a single set. And then I flip 2 over to show the fraction 2/3. Now, when I'm working with these 2 color counters, I always like the red side of the counter to represent the numerator. And why I like to do that is because when students are drawing fractions, they often shade to show the numerator. So if I ended up drawing 3 circles, and I don't have a marker to do that, so I'll go ahead and do this over here on the slides. But if I was just quickly drawing 2/3, I would draw 3 circles like that, and I would quickly shade 2 of those to show 2/3. And so that has a kind of a nice relationship to the red
counters, whereas the one that's empty has a nice relationship to the yellow counter. So that's why I always like my red counters to represent the numerator and the yellow counter to represent the denominator. Yeah, the denominator. I said that right. So let me go ahead and erase this, and we'll go to our next slide, which is talking about the set model of fractions in sum. So with the set model, fractions are appropriated by a set of items, and it can be anything that you have. It might be markers and a crayon, or shapes or colors, or anything. The two color counters are great, but they're not necessary. So if you have any other shapes or objects, you're welcome to use those with the set model. So let's look at workbook activity number 3. Here I want you to see how this student represented 4/5. They tried to use the set model, but they weren't exactly successful, as you will see. So how could you use the set model to help this student understand the fraction 4/5? Go ahead and draw and write your response.
All right, so we've been focusing on different models of fractions to really help give students a strong foundational understanding of what fractions mean and how we can represent fractions. So I introduced all these models pretty quickly. We talked about the length model of fractions, the area model of fractions, and the set model of fractions. But these really should be introduced separately and practiced until students have a good, strong understanding within each of those models. And we can use a lot of the concrete manipulatives like I showed, or the different representations, and they should be helpful to a lot of students, but remember, they may not be helpful to all students. So that's why we always need to fill up this toolbox with lots of tools that you can use, but you may not necessarily use all of these tools for every student when you're thinking about providing good intensive intervention. And why are all these models important? I think that's a nice thing to circle back on. Well, when you look at textbooks, when you look at workbooks, when you look at standardized test release items, students will be asked to interpret and work with all 3 models of fractions represented pictorially. Just flip through any standardized test and you're going to see the area model, you'll see the length model, and you'll also see the set model. So if we practice those enough, students should have a good understanding of those and then do very well on those items. And really, as I said before, this understanding of core fractions is a gatekeeper to algebra. So the more that we work with students and really help them understand what fractions represent, it's going to help them later on with many other things that they learn in mathematics. Now, we've been focusing on fractions. Fractions are really they're the most, I'm going to say they're the most important thing within rational numbers that students do need to understand. But we also have decimals and percentages. So I'm just going to briefly talk about a few important things that if you are providing instruction on decimals or percentages within intensive intervention, that you need to be thinking about. So for both decimals and percentages, we really need to emphasize place value. Many students have a hard time when it comes to decimals and percentages because we've been talking about hundreds, tens, and ones, hundreds, tens, and ones, or maybe even thousands, hundreds, tens, and ones. And then all of a sudden we say, hey, look, there's tenths, there's hundredths, there are thousandths. And those are actually hard for me to say. They might be hard for you to say, but you really need to emphasize those THSs at the end of those words. So we have to emphasize place value and make sure that students understand what a tenth represents, what a hundredth represents, and so on. We also need to help students understand how to read different decimals and percentages. This is where the word and can come in. Many people will say numbers like 114, they'll say 114. That is incorrect. Really, the only time that you can use and is when we see a decimal point, or really from the break from whole numbers to rational numbers. So in fractions, I can say 2 and 1/4. It's the break between the whole number and the fraction. In decimals, if I was saying 2 and 25 hundredths, that's how I would say that. I shouldn't say 2.25. That's an informal way to read that fraction. It doesn't get to the math at all. But if I say 2 and 25 hundredths or 10 and 4/10ths, I'm going to really help students understand not only how to read those fractions, but it also goes back to the place value of those fractions. So when we're thinking about representations that can help students understand decimals and percentages, The two best ones to use really are base 10 blocks, and we can also use money. Money is really helpful. We can use dimes and pennies to represent the tenths and the hundredths in $1. But I'm going to go over here and just show, I'm going to look at these two decimals, 25 hundredths and 1 and 9 hundredths, and I'm going to think about how we could use our base 10 blocks to show these two different decimals. So I've got my base 10 blocks, and a lot of times we use these within whole numbers. So we have our flats, our rods, and our units. And with whole numbers, these represent hundreds, tens, and ones. But when it comes to decimal placement, I can reinterpret these base 10 blocks. So my flats become 1, or they represent the whole. My rods represent the tenths because there are 10 tenths in one whole, or 1. And then my units, those become hundredths because I have 100 hundredths in a whole, or in my flat. So now I can think about showing fractions. I said I was going to do 25 hundredths. So 25 hundredths, I have 2 tenths in 25 hundredths, and then I have 5 hundredths, and sometimes I might bring in something else I could there that can represent my decimal point. So here I have represented the decimal 25 hundredths. I can also represent the decimal, I was going to do 1 and 9 hundredths. So I'm going to clear this. Here I have 1, so my flat represents 1. I have 0 tenths, and yet I have 9 hundredths. So I'll get those over here. So if I was reading this, I have 1 and 9 hundredths. Now I don't have one here, but many times it's helpful to have a place value mat. You could also just take a marker and write ones, tenths, and hundredths in the same way that you would use a place mat for hundreds, tens, and ones. I can also, I'll go ahead and do it. I have 95%. I could show that with my base 10 blocks. It's going to be, I think I can actually do this. So I'm going to set out my flat and then actually put my tenths on top of it. And I need 9 of those because I'm going to show 95. I think I can get them all on there just a bit. And then I need to show 5 ones here. 1, 2, 3, 4, 5. So, and then I can show that I'm covering 95% of this flat, and that represents the percentage 95%. And I could also see that it represents 95 hundredths. And those are going to fall off there. It's a little bit hard to do. Sometimes it might be better to actually have a different colored flat, and then maybe like a yellow flat and the blue tens or tenths and hundredths in order to be able to do that. But as I said, money is a really nice manipulative to use here. Often if students have a strong understanding of fractions, understanding decimals and percentages kind of comes naturally. So I would spend the most time thinking about developing fraction concepts and then developing decimal concepts and concepts around percentages. So this whole part of this module was revolving around that question about what rational number core concepts should you emphasize within intensive intervention. So things that would make me really happy would be to teach the length model of fractions, to teach the area model of fractions, to teach the set model of fractions, and then also to teach decimal and percentage concepts. You may not be teaching all of those things at one time, but as students are really starting to understand and learn about rational numbers, you should be teaching each of these 4 things.
Welcome to your discussion board activity for this part of the module. Here, I want you to share the favorite tools that you use when teaching about fractions. So this is going to help you share what you know, and you're going to gain a lot of knowledge from your colleagues. I want you to describe why each tool is helpful and how you might use this tool for modeling or practice within explicit instruction. And you're welcome to share a video of you using different tools to teach about fractions, or if you want to do decimals, that would be fine as well. And you're also welcome to share print materials. Have fun with this one.